dear candidates, where we stopped under the topic transformations, we were looking at enlargements as a subsection of transformation. An enlargement, I want us to proceed from there. An enlargement is a form of transformation in which the image is reached by the help of two fundamental concepts. That is to say, as you recall, the center of enlargement, and mainly the linear scale factor, K. Remember, we said this scale factor is positive or negative, and it's a fraction, stroke integer. Not to forget. The fundamental method we use here is the displacement from the center to the image is reached. I use equal signs there. The displacement from the center to the image is reached by getting our linear scale factor K multiplied by the displacement from the center to the object. And these are distances. These are just distances. However, the method is transformed. This method is similar. The method is denoted as the displacement from the center to the image as a vector is equal to K times the displacement from the center to the object. This is what we normally use, so commonly used. However, it teaches us one concept under enlargements, that every time we are doing any measurement, which will be so fundamental under the graphical approach, that every time we are doing any measurement, we begin from the center. In the two displacements, the center comes first. And since we have been able to transform these distances to vectors, it communicates that the order is not altered. The order must not change. Measure from the center to the image, as long as you have the distance from the center to the object multiplied by the scale factor. We want to look at some examples here for us to brainstorm the idea. Example 1. A point A of coordinates 1, 3 undergoes an enlargement. Of scale factor -3 about the origin or determine the coordinates of A prime being the image of A. So from our idea class, which communicates that the displacement from the center to the image is equal to the scale factor times the displacement from the center to the object, I emphasize that when a candidate is doing the solution, should transform. Please transform the question to suit your method here. So our center is the origin, that one we leave it as the center. Our image is A prime. Our scale factor remains K. Our center is C, but our object, if the image is A prime, it automatically means the object was A. Object is A, its image is A prime. These are put down as vectors. Slightly, all of us candidates know something about vectors. To recall, a vector AB, we could shortly say it's the same as OB minus OA. What's the idea here? Position vector of the last letter minus the position vector of the first letter. So in this situation, we will simply say positioning vector of the last letter minus the positioning vector of the first letter is equal to k into positioning vector of the last letter minus the positioning vector of the first letter. If you have the coordinates, then the positioning vectors are obvious. Since we don't know the image A, we will take its positioning vector to be unknown. We are under matrices. The positioning vector is a column matrix. OC is the center. Our origin, about, keyword, about. When we are told that about a certain point, the origin is 0, 0. Origin means 0, 0. So, about the center. About automatically implies the center. So, OC is 0, 0, which is equal to K into. So, into OA. OA is 1, 3 minus OC, which is our center, about the origin. In the question, it's a keyword used, not the center, but about implies it's the center, 0, 0. So our K was given as negative 3. On the next step, we can substitute x minus 0, y minus 0, like terms. Our K is negative 3 into 1 minus 0 and 3 minus 0. That gives us x, y corresponding to 3, corresponding to negative 3 into 1 minus 0, which is 1, 3 minus 0, which is 3. So resultantly, class will end up with this is negative 3 and negative 9. Remember, all of us from matrices, we recall that whenever a constant is multiplied or is pre-multiplied into a matrix, it hits every entry. So negative 3 multiplies 1 to give us negative 3. Negative 3 multiplies 3 to give us a negative 9. And therefore, since we know the values of x and y, x is negative 3 and y is negative 9. Remember, any coordinate is in the order x, y. That means we are ready to write down the coordinates of the image of point A, which will be negative 3, negative 9. That's how the concept of an enlargement is utilized when dealing with questions of especially section A. So, dear candidates, we are going to example number 2 to further see what if instead it's not the image that is required, or the scale factor is required, or the object itself is required in return. What do we do? Example 2. Example 2. Example 2. So in our example 2, a point B of coordinates negative 2, 3 undergoes an enlargement about 1, 1. So this implies this is the center of enlargement. To produce or to map it onto the image B prime negative 5, 5, we have to find the linear scale factor of enlargement. So this time round, it's the scale factor of enlargement which is unknown. So let's go to the solution. So as we see, the object is B. It is mapped onto B prime, the coordinates as in the question. Our scale factor K is not known. However, the center of enlargement is known. It's 1, 1. Back to our conceptual approach method. Center of enlargement to the image. That displacement is equal to the scale factor times the displacement from the center to the object. Now, as we say, transform the method to the question. So our center is C, but the image is B prime, and our object is B. When we use vectors as earlier discussed, this is the same as OB prime minus OC, which is equal to K into OB minus OC. OB prime is negative 5, 5. Subtract off the center. Coordinates are 1, 1. Writing them down as a matrix. Our constant or scale factor, we don't know it, but we know the object. The object is negative 2, 3. We don't know the center. Rather, we know the center, which is 1, 1. The other side, we have negative 5 minus 1, 5 minus 1, which is equal to k into negative 2 minus 1 and 3 minus 1. This gives us negative 6, 4, which is equal to k into a negative 3 and a 2. When you open brackets clearly, this will equal to negative 3k and 2k. This is the point, if you recall from matrices, we call it equality of matrices. When two matrices are equal, in other words, their coefficients are all the same, the like entries balance. In other words, negative 6 is equal to negative 3k. Dividing both sides by negative 3 by negative 3. This gives us k as 2. And 4 being equal to 2k, we divide both sides by 2. And this leaves us with k as 2. In such a situation, when both values got of k are the same, you're set class to conclude, dear candidates, at this point. You can conclude and say, therefore, the linear scale factor k is 2 of enlargement. In these questions, sometimes it is the center asked for, it's the object asked for. It can be the scale factors seen asked for, as long as you apply this concept the right way. Through our website, we are going to send you practice questions to further brainstorm this concept. And we wish you the best as we go on to the next concept under the same subsection of transformations. Thank you.